Alright, for question 8, a law enforcement agency is evaluating potential candidates on two main characteristics, intelligence and physical prowess. Intelligence is measured on a scale from 1 to 16, with a smaller score representing a more desirable intelligence. It's very important. And from the data collected on all candidates, we have the mean, which is a 9.6, a standard deviation of 2, with a max score of 6.8. And based on this relationship, between the mean, the standard deviation, and the max score, they want to know if it's reasonable to believe that the distribution of the scores is approximately normal. Okay, so what they want us to do is they want us to determine from this max score if this distribution could be approximately normal. So what we're looking at with a max score on the normal curve, this max score should be in the 99th percentile or 98th to 99th to be approximately normal. So what we need to do is we need to take this score of 6.8, given the mean, given the standard deviation, and calculate its z-score. So its z-score would be equivalent to 6.8 minus 9.6 divided by 2. So a negative 2.8 divided by 2, so z equals a negative 1.4. Now, given that this lower score is actually more desirable, that this is a max score, our z-score should not be negative, it should be positive. What we're saying is that we're 1.4 standard deviations better than the mean. So the next thing we have to do, given that we have a z-score of 1.4, which again just corresponds to 1 point standard deviations better than the mean, we need to take this and we need to find its corresponding percentile on a normal curve. We can do that using the chart, or else we can use our graphing calculator. This should be a normal distribution from the negative 99th standard deviation up to 1.4. What we have is that this score corresponds to the 92nd percentile approximately on the normal curve. So this z-score is approximately the 92nd percentile. Now, given that this is the max score, to be normal, this max score ideally should be in the 99th percentile. I would say if my pen would work, but no less than the 98th percentile. Therefore, this distribution, given this information, given this relationship, is not approximately normal. Now for part 2, we're talking about physical prowess. And it's measured on a scale from 1 to 60, where in this case a higher score is representing a more desirable intelligence. From the data collected on all candidates, the mean prowess score is 49, with a standard deviation of 6 points. Calculate and interpret the z-score for a candidate who scored 42. So calculate the z-score. We have 42 minus 49 divided by the standard deviation of 6. So we have a z-score of a negative 7.6 or a negative 1 1/6. Now again, we're not going to change the sign here, because in this case, this score is in fact less desirable because it's lower than the mean, and in this case a higher score is representing a more desirable physical prowess. Now the biggest mistake that people make is they automatically take this z-score and they convert it over to its corresponding percentile on the normal curve. The problem is we don't know that this distribution is normal. Now we do know that intelligence is not, but we don't know about physical prowess. So unless we state that assuming this distribution is normal, we should not convert this over to percentiles. So people are asking, well, then how do we interpret? Well, a z-score just simply means how many standard deviations above or below the mean a particular score is. So in this case, this means that this candidate scored approximately 1 standard deviation below the mean. Now what this means is that if they scored 7 points below, which given a standard deviation of 6 points means that they scored a little more than 1 standard deviation below the mean, and that's it. Now you could say that assuming this is normal, then you can convert this over either using the chart or the calculator to a percentile, but without saying assuming this is normal, making that assumption would be incorrect. So this is all you would have to do for part B. For part C, it says which candidate is more desirable on paper. So what we want to do is we want to calculate each z-score, okay, for candidate A and for candidate B. So what we would do is we would say z equals 9.1 minus 9.6 divided by 2. Okay, this is candidate A. For candidate B, 9.9 minus 9.6 divided by 2. For physical prowess, it would be 51 minus 49 divided by 6. And for candidate B, it would be 60 minus 49 divided by 6. So what we get here is we get a z-score of a negative 0.5 divided by 2, or negative 0.25. Now remember that this score of 9.1 is actually more desirable. It's better than the mean. So we would make sure that when we use this, we would use it as a positive 0.25. Okay. Over here, the z-score is equal to 2/6, or 1/3. Okay, in this case, this score is better than the mean, so we're going to leave it as positive. For candidate B, what we have is we have 0.3 divided by 2. Now, in this case, this z-score is actually worse than the mean. I'm sorry, this value of 9.9 is worse than the mean value of 9.6. So this should actually be a negative z-score. Okay, of 0.3 divided by 2. Okay, this is actually a negative z-score of negative 0.15. Alright, now we need to calculate the z-score for their physical prowess. And we have 11 over 6, which is equal to 1 and 5/6. So what we want to do is we want to determine which of these candidates is better. Now we found their z-scores, so we've standardized these values. So to determine which one's better on paper, really the best that we can do with the information we have is just average these together. So when we take the average for candidate A, we have 0.25 plus 1/3. Okay, we take that value, we divide by 2. They have an average z-score of approximately 0.3. Okay, they're averaging approximately a positive 0.3. Okay, for candidate B, we have 11/6 minus that 0.15. We divide that by 2, and we have approximately 0.84. So on paper, candidate B is definitely the more desirable candidate. Again, we don't want to convert these over to percentiles because we know that intelligence is not normal. We're not sure if physical prowess is. So making that assumption again would be incorrect. Knowing that intelligence is not normal, then all of a sudden assuming physical prowess really does not do us any good. Because even though we might be able to convert that over to a percentile, we know for a fact that we can't for intelligence, so we just shouldn't do it. We should stay away from that. Now what they ask us in Part D, they say if intelligence is weighted to be 5 times as important as physical prowess, does that change your answer to the above question? So what they're saying is that intelligence counts 5 times, where physical prowess only counts once. So if we look at candidate A, we have the intelligence of 0.25 counting 5 times. We have the physical prowess of 1/3 only counting once. Okay. So to find the average, what we would do is we would take that value and we would divide by 6, because again we're taking 0.25 and we're counting that 5 times or adding it 5 times, and then we're adding 1/3 once. Okay, dividing by 6 will give us the correct average. And for candidate B, what we're going to do is we're going to take that negative 0.15, we're going to count it 5 times, and we're going to take that 1 5/6, and we're going to count that once, and we're going to divide that by 6 to get the average. So when we do that calculation, and divide that value by 6, what we get is an average z-score of approximately positive 0.26. For candidate B, we have the negative 0.15 times 5 plus the 11/6. Divide that by 6, and we get approximately 0.18. So, have we changed our answer to the above question? Yes, we have. Because if we weight the intelligence score of candidate A 5 times as important as the physical prowess, same for candidate B, candidate A is now a better candidate on paper. Now for the last question, it says, given this situation, is there danger in averaging these z-scores? If so, why? Now given the information that we have, this was the best that we could do. But is there danger? Yes, there is danger. And the simple answer is because we don't know if these distributions are normal. In fact, we know that intelligence is not. Okay? And why that's a problem is because if the distributions aren't normal, a z-score of 0.15 on intelligence could be much worse than a score of 0.15 on physical prowess, depending on the skewness of the data. And that has to do with where the mean is and where the median is and how the percentiles would be divided up. So there is danger. Now, just because there's danger doesn't mean that we shouldn't do it. A lot of great things have been discovered when people decided to go ahead with something despite the danger, but they were well aware of what might lie ahead. And that's what you need to be aware of. And when you're reporting this data, make sure that that's very clear, that you understand it, and whoever you're presenting the data to also understands that. So yes, there is danger because we don't know if these distributions are normal. So these z-scores really shouldn't be measured on the same scale. Within intelligence they can be, within physical prowess independently they can be. When you start averaging them together, there is a little bit of danger. Doesn't mean that we shouldn't do it, doesn't mean that what we've done is not correct, but you should be aware of it. And that's how you would finish question 8. Hopefully that helps.